All right. So thank you very much for following this particular series of training tutorial videos. Yeah. I think on Monday I started the training with the University of Energy and Natural Resources at Sunyani in Ghana, and I decided to make some part of the trainings available for the Tech Foundation community. Now, initially, we wanted to stream it live. Unfortunately, we had some internet issues, so we couldn't do that. All right. I did some offline sessions, which were supposed to be an addition to the main content I treated in the class. Okay. So it's kind of this tutorial of class tutorial series is not the whole complete picture, right? But for the students who participated in the training, they will get the whole thing, right? So I also tried as much as possible to make it useful to anyone who would be watching this off class sessions online. All right. So we started on Monday. We said I said that I want us to develop a development board that I would use to teach the Arduino, so that by so doing, the students, those who are new to Arduino, can know how circuits are built using Arduino. Okay, and it's also an opportunity to record a video on how I locally manufacture PCB. Now, everything came as a side plan. It wasn't the main plan. Okay, it was after I got here that I realized that doing something like this would be cool. So I had to quickly put together a couple of things to make it possible. Okay, so that's why I didn't do. I may have done things not quite the right way, like not using gloves and other stuff during the PCB. But hey, it still goes well, right? Okay, so we developed the PCB, and then yesterday I soldered the components on the PCB. So here is the board that we designed. Okay, is the board. You can see that the back here is quite not so bad because during the development, the printing didn't really go well. Okay, on a scale of 1 to 10, I will give it like a 7. Okay, because I've done better boards than this, but all the same, I think this is all good. There were a few patches to be made, which I did. Okay, so let's take the board for a run. So what I'm going to do in this last of class session is to test the board out. I already used it in class yesterday, but because I did it with you, I wanted to give you a feel of how everything worked out. So we're going to program this. There are a couple of things that we can program, but since the main activity was to develop a model traffic light, I'm just going to program the model traffic light session. Yeah. Now I'm going to I'm not going to do a tutorial on Arduino, okay, Arduino programming. However, I intend to do a series with this either before March or during March. Now, in March, the Tech Foundation will kickstart the Tech Foundation Project IV, and the whole of March will be dedicated to training. Okay, so I'm still thinking about how to run the whole thing. Either I'll use this development board as the board for the training, the programming aspect. In which case, I'll try and make it available for all those who will be interested. Okay, yeah, if I'm unable to do that, then I'll try and find time and do a complete basics on Arduino Uno programming, okay, which should be very useful to any beginner and probably up to an intermediate level. All right, so let's get started. So over here, I have opened an Arduino IDE. Okay, so we're going to put in our code. And for those who already know how to program in Arduino, you realize that these are two basic functions that are required. In case you are coming from a C++ or Java background, every C++ or Java application needs an entry point called main, right? Now, in Arduino, you need these two. This first function is the setup function. It's used when for everything that is a configuration for your application, things that should run one time and at the beginning of your code. Okay, you put them here. And again, I'm not going to do this, is not supposed to be a complete tutorial on Arduino, so I will just talk about a few things. And everything that we want the application to execute over and over, those are the things that we are going to put in the loop. Okay, now I also saved, I actually saved, where is it? Where is it? Where is it? Okay, so the pin mappings. So I also have the pin mappings over here. Okay, so just for reference, now since we are only working with the traffic light aspect, we need from pins 3. So direction 1 red starts from, so direction 1 red is 3, amber is 4, okay, 5, then direction 2 is 6, 7, 8. Okay, so I intentionally arranged it that way. Okay, so that means that these are the pins that we're going to use for our work. Well, if there happens to be more time, I may touch on other things that the board can do, but for now let's just focus on the traffic light. Okay, so again, I'm going to program as if you already know it. Not going to talk so much about the teaching of the whole thing. All right, so let's do some programming. I'm first going to create a const byte array come on, byte array. Let's call this signals. Okay, and I'm going to create it as a 2 by 3 array. Okay, so the first side, the 2, represent the directions. Okay, we created for a T-junction, so technically we have just two directions, right? Direction 1, direction 2, and the 3 would hold the lights for each direction. So for each direction there are 3 different signals: the red, the amber, and the green. Right, now take a look. This is how I am choosing to program it. Right, you can actually put it in a single array, or even if you want to be very crude, you can just declare different variables for them. Right, but I'm just choosing this approach. It sounds cool, right? All right, so the 2 represent the 2 directions, and within each direction there are 3 lights. Okay, also I'm going to declare the sizes, so I'll do const byte directions, and I'll set it to 2, and also const bytes, and number of signals, I'll set it to 3. Okay, I'll be using this as a guide. So there are 2 directions, each direction has 3 signals each, right? Okay, now right now we want to be switching on the light, and probably let me show you uh, the key card. Let me show you what we did in the schematic, so that you can appreciate why we are doing what we are doing. Okay, so I'm opening the key card. Probably let's get the PCB up. Okay, PCB is opened over here, and let me quickly bring up the 3D view. All right, so this is the 3D view of what we've done. Okay, so right now we are only trying to program the light. Okay, there are other things like GSM, RTC, and some other stuff that we can do with this board, but then this is just to demonstrate to you that what we did was actually successful, so I wouldn't be touching on the other ones. Okay, all right, so when we look at the schematic, each light module or each set of LEDs are switched by a transistor, and the transistor is switched by what? The Arduino. Is that okay? So we're going to use the Arduino to turn on the base of these transistors, which will in turn switch on the lights themselves. Okay, so that's what we are going to do. Okay, so since we are trying to switch on lights, that means we have to configure our Arduino pins as what output. Is that okay? Oh, I forgot something. I actually have to put in the pins. So since this is a two-dimensional array, it's a multi-dimensional array. We said that the first one, direction one, the pins associated with direction one are 3, 4, and 5, and then direction 2, 6, 7, and 8. Okay, so I intentionally arrange them this way so that it will be easy to deal with. Okay, so what we're going to do next is to output pins. To do that, I'm going to use a for loop. Now, since we are doing, I can actually do this for loop in two different ways. Okay, I can use a single for loop to do that, but just for steady sake, I'm going to use two for loops, two nested for loops to do that. So I'll start with 4 bytes. D equals to 0, D less than directions. Okay, so the D is the number of the directions, D plus plus. Then within this, I think I've done multiple stuff. Okay, then within this, I'll do for bytes S equal to 0 to target the signals, S less than N signals, S plus plus, right? Okay, then all I will do now is to set pin mode. Okay, so because my pins are in a two-dimensional array, to access them, I'll do signals, okay, which is the name of the main array. Then the first one will be which column I want to access, okay. So the column is controlled by D, and then which row, is it row column? I think it's, yeah, column row, whatever. So the first one is selecting, I think this will be row. Yes, this will be row. The first one is selecting the row, and then the second value is select the column. Is that okay? So the column is controlled by the variable S. So I'll put S over here. Control T to format my code. Now, this is also what I want to do. After configuring the pin, I want to turn on that light to serve as something like I'm initializing the light, right? And to do that, we need digital rights. And again, over here, we have to specify the state, the output. Output, okay. So we are configuring all the pins as output. Now, let me just copy this and bring it here. So after we've configured the mode of that pin, we will test it by writing it high and then delay for just, let's make it 1 second, right? And then we write it off. So I'm gonna duplicate this loop, okay, with this loop, right? So what this is going to do is to iteratively set the pin modes of all these pins, and once it's done setting the pin mode, it will switch on that light briefly for a period of 1 second. Then it goes off, go to the next in that order. Is that okay? So probably let's just take a spin. Oh, I think, let me select the board. Oh, I haven't connected it. So I'm gonna connect the board to my computer and then switch this on. Now remember, we built this around 12 volts, okay? So I'll leave it on 12 volts, as you can see in the power supply. Is that okay? All right, so yes, COM and the board is Uno. So Arduino Uno COM5, that is good. So now we can upload code onto our board, right? Okay, so let's push this first code and see how it works. Oh, okay. Over here, I missed that. All right. Great. Let's upload. Okay, so it is done. What's happening? Coming. Just a moment. Oh, okay. So it happens that I had actually not connected this. Okay, so let's push it in now and restart the board. Okay, so you can see everything is happening as so everything works, right? So now let's write some traffic code. Now I'm going to define a function. I'm going to define a function. I usually like to keep my setup functions at the top of my code. So I use function prototypes a lot. Okay, function prototypes. Okay, now the first function that I'm going to define called void switch LED. Okay, and this switch LED function will take bytes direction and then byte signal. Okay, so this is the signature of the switch LED function. Okay, the signature of the switch LED function. And then I will define it down here. Okay, so what would this do? Let me just borrow this over here, put it there. I can actually optimize this code by doing things parallel, right? But then, I mean, it's not every time that you have to be so stringent and some stuff. So I'll just assume I don't have to do that. Okay, so I'll get rid of these two pieces. Okay, I'm still going to use these controls, but then I'm going to do something simple with this. I'm going to use a ternary operator to do something. So what I want to do is this. I'll say that if s, okay, equals to, if d equals to direction and s equals to signal, right? Then what I want you to do, so this is called a ternary operator. I want you to switch that particular thing high, I'll set it to low. Okay, so just this line, that will make sure the right lights turn on and I don't have to do any much. That's all. That's all I want to do in here. Okay. So now in my for loop, in my actually I need this up here. Okay, I need this. Undo what? Okay. Add it again and paste it here. Okay, usually in my code, I want setup and void to be the first two functions and every other thing follows. Okay. So now we're going to arrange the order of the code. Okay. So this is what we're going to do. When it starts, when the lights start, I want both signals, both directions to be red. Is that okay? To be on red. Okay. So I'll say 10, 10, 10 all directions. Okay, let's rather use the right things. Stop all directions. Okay, stop all directions. Then after stopping all, the next thing will be switch direction 1. Okay, or let me make it move direction 1. Move direction 1. Okay, get direction 1 ready to stop. Okay, then move move come on, move direction 2. Get direction 2 ready to stop. Okay, yeah, this should do the magic. So what do we mean by stopping direction one? Is that okay? So this means that you do switch. We will call the switch LED method. Now we want to stop direction one. Okay, now so direction one will be D0 and the first signal will be 0. Is that okay? So if you take direction 1, since it's an array, direction 1 will be index 0 for the row and the column 0. Okay, so this is the signal that I want to switch on. We also want to switch on that of direction 2. So switch LED. This time is going to be 1 0. Okay, so this will turn on the red light. However, we just want this to be done briefly. Okay, so I'm going to set just a delay of 1000 seconds. Is that okay? Delay of 1000 seconds. Then we move to, I really hate the way this thing is formatting my code. Alright, so now the actual thing begins, which will be move direction 1. So to move direction 1, that means we turn direction 1 on green. Can the new Arduino editors, developers fix this thing? I really hate the way it's automatically. Anyway, that's why I actually use Visual Studio Code for development, so no problem. Let's just deal with it. Okay, so to move direction 1, it means that we're going to move, set it on green. Switch LED. Direction 1 would be 0 and its green light will be index 2. Okay, that signal will be index 2. Now, when we do this, remember the direction 2 is still on red and we keep it on red, right? But we need to delay this for some time, so let's set this to 5 seconds, which will be 5000, right? After which, now get ready to stop direction 1. That means that we set it on amber while direction 2 is still on red. Okay, so again switch and direction 1 is 0. Amber will be index 1. Okay, and then for amber we want to delay by just 2 seconds. Okay, seriously, you guys gotta fix this thing. Okay, I don't know if somebody knows how to fix it in here. Please let me know in the comment section. Okay, it's really annoying. All right. So delay, we put a delay there. Now the next thing we want to do is to move direction 2. So to move direction 2, that means that put direction 1 on stop and put direction 2 on green, right? So again, we switch LED. We first have to stop direction 1, so by setting it on red, and then we switch direction green. So direction 2 green is going to be 1 2. Okay, yes, this switches direction 2. Then we have to also put a delay, and like we did for the previous one, we put a delay of 5000. This is like the time it takes for the cars to move, right? Mostly it's around 30 seconds or 25 seconds there for a real traffic light. But we can be waiting for 30 seconds. So let's just put this down. Then the next thing to do is to get direction 2 ready to stop, right? So that means we set direction 2 on amber. Direction 2 amber will be 1 1. Okay, direction 2 amber would be 1 1, and we put a delay of 2000. Okay, and that is it. So I think the ideal place to put this first set of code will be at the bottom. Okay, so that when it starts, it rather starts moving. So I'm going to move this code to the bottom. Okay, so technically I can omit this code since we don't have any pedestrian crossing or something like that, but I'm just putting it in there so that in case a driver made a driver moved when it was on amber, he will have some allowance of time to move before the other direction starts moving. Okay, so this is just a safety feature that I'm just putting in. Okay, And I mean, depending on the nature of the uh, junction, probably the city engineer, the civil engineer on that project may advise, give some advice. So you, the programmer or the developer, you just have to put his suggestions into code, and that is it. Okay, so I think we good. So you see, by writing this switch on function, we get to have a very clean output, right? And everything is just so neat. And don't get it twisted. This is not the only way you can program a traffic light. Okay, you can do, I mean, whatever you want to. Just that some ways will be efficient than others. Is that okay? So just pay attention to how you are coding it. I'm not really interested in efficiency here. I just want to test my bots, okay, so that you guys will know that what we did actually worked. All right. So let's assume everything is good, which I think it is. Well, let's save and upload the code. Okay, so we have an error here. Let's try and fix it. Okay. Let me quickly handle something real quick before my machine freezes. All right, this thing is really annoying. Just a moment. Okay, here we go. All right, so let me fix. It says the error says that expected colon before. Ooh, oops. What? Oh, here. Sorry, it's not supposed to be a comma. It's supposed to be a colon. Okay, let's try again. All right, I think everything is loaded. So let's see if it's initializing. I mean, I could speed up the time for initialization. Oh, all right. So actually, yeah, because I moved the code to the bottom, I really have to revisit the order. Okay. So over here, we only switched on direction one because previously the red was up there. So let us do justice to that. I'm gonna duplicate this code. So first we put direction, we switch on direction. This is supposed to switch a green. Oh, sorry, wrong place. All right, so duplicate this. So we switch direction one on green, direction two has to be on red. Okay, direction two has to be on red. That will be 1 0. Okay, direction two has to be on red. Let me look at the pattern again. What else doesn't make sense? It's like they're only switching once. Oh yeah, my bad. So you can see that the lights are turning on one at a time, right? The lights are turning on one at a time. This is because the loop is actually switching everything off, keeping only one. Okay, so let's do something. Let's do something. Uh, let's do something. I don't need the two loops actually. So I'm gonna keep only the inner one. Sorry, I really never thought of that. I really never thought of that. Okay, so I'm going to keep just this inner one. Still, I'll pass the direction and the signal, but we are only going to loop on the signal, not the direction. Okay, I think this should solve the problem. Yeah, sorry for that. It's really oh, okay. So in place of D, I'll put direction. Okay, so direction. This time we don't need this. We only need to, yeah. So direction that we compare whether the signal is equal to what we have, what we have passed, and we switch it. Okay, all right. Okay, so let's upload this one more time and see the magic. Let's see. Okay, so initializing. I could actually initialize them together too. All right, so red and green, then it goes to amber, then it goes to red, then the direction one goes switches to amber, and they all stay on red for a second, and the cycle goes over and over and over. Okay, so like I said, I just wanted to demonstrate to you the fact that the board that we created is working as intended. Okay, I'm still thinking about what to do, whether to make it as part of our training in March or just record some freestyle or unscripted um, programming lectures on Arduino. Okay, so let me know what you think. If you want more of this, if you want me to do more of this training or bring you more of videos on programming Arduino using this board, just give me a comment in the section. Okay. Once again, I'm Professor. Don't forget to share this video, like it, and subscribe. Please subscribe. Okay. It takes so much work to do this work. So if you're enjoying it, then try and subscribe to the channel so that we can also benefit from it. All right, thank you. This is the last video for our off-class sessions. It has been a nice ride. I'm always proud to be your tutor. My name is Professor, and I am committed to giving you your Eureka moment. Thank you.